This video will talk about supremum. Supremum is considered as the least upper bound of a set. Now, prove that if the supremum of A and supremum of B exist for A be a subset of B, then the supremum of A is less than or equal to supremum of B. This is its actual statement, that A and B be subsets of real numbers, with A be a subset of B. If supremum of A and supremum of B exist, then the supremum of A is less than or equal to the supremum of B. Given that in this case, it's a possibility that B is a set larger than A, since A is a subset of B, then the least upper bound of B, that's the supremum of B, is still greater than or equal to the supremum of A. We need to show a proof for this one. Let us start by structuring this proof. Let A and B be subsets of the set of real numbers. Okay? With, let's have here, A being a subset of B. It may be equal to B or a proper subset of B. Nevertheless, A is a subset of B. Okay. Now, let us have here a representation for supremum of B. Let's say, let M be equal to the supremum of B, or in short, M is the least upper bound of the larger set B. If that would be the case, that M is the least upper bound of B, then we can say M is greater than or equal to B for all B element of set B, because it's the least upper bound. It might be the largest element. M may be equal to the largest possible value of B, or even greater than that, because that's how it is meant to be. Now, given this idea that since A is a subset of B, let's leave this in the meantime because we are going to introduce here A, set A. Since A is a subset of B, then every element A, which is in A, is also in B, since A is a subset of B. The point here of sharing this is the implication that our supremum of B, which is denoted as M earlier, is also greater than or equal to A for all A element of set A, since all of these are also element of set B, given that M is already greater than or equal to all elements of set B. Because here's the catch, if we have this set B and this is set A, if M being the supremum, okay, of set B, then it is also greater than or equal to all elements in A, because A is just part of B. This further says, which implies that M is also an upper bound. Let me have the black colored pen. Upper bound of A, right? Because in the first place, it's also an upper bound of B. Now, given this idea already, that M being the supremum of B is already the upper bound of B, and it's also the upper bound of A, we can now look into two different scenarios. Because M could be an element of A, or just an element of B but not of A. Okay? Because it could be an element of A here, which is also an element of B, or it could just be an element of B but not of A. So here are the two scenarios. If M is an element of A, and since M is already greater than or equal to all the elements of A, then we can say that since M is the upper bound of A, and in short, it's also greater than or equal to all the elements of A, then M is also equivalent to the supremum of A. because supremum of A is the least upper bound in A. And since M is already that, then M is the supremum of A. Next, if M is not an element of A, but of course we know that M is already the supremum of B, hence M is an element of B, okay, then we can say that M, which is the supremum of B, is greater than whatever would be the supremum of A. Because M is already the least upper bound of B. If it's just an element of B but not of A, if you could find here N, any N supremum of A, this is still, M is still greater than that. Because M is in the first place greater than all the elements of B and all the elements of A. Now, here are the two scenarios. Combining them, okay, thus, M earlier is already defined as supremum of B. We can now say that M being supremum of B is greater than or equal to the supremum of A. Therefore, we can say that, let's simply reach this, we can now say that the supremum of A is less than or equal to the supremum of B. This is the proof for this statement. Okay? So going back here, we have assured that M being an upper bound of B, and since A is a subset of B, M is also an upper bound of A. And for two cases here, we have combined them into this, and further say that really the supremum of A, whatever it would be, is just less than or equal to the supremum of B, depending on the scenario. Thank you very much for watching.